Hey, welcome. Let's talk about energy. You know, the invisible force that's powering pretty much everything around us. From the screen you're looking at right now to the lights in your room, it all begs the question, where does this stuff actually come from? Well, let's get into it.
Really think about it for a second. You flick a switch and boom, light. It feels like magic, right? But it's not. It's this huge, incredibly complex global system, and today we're going to pull back the curtain and see how it all works. Okay, so here's our game plan. First, we're going to meet the real unsung hero of power generation. Then we'll look at the main ways we get that hero to do its job, first with heat, then with movement. After that, we'll talk about the one big exception to the rule. And finally, we'll get into the really tough choices that come with all of this. All right, first up, our world of energy. Now, here's something that might blow your mind. For all the different ways we make electricity, from burning coal to splitting atoms, you name it, almost all of it boils down to one single, surprisingly simple idea. And here they are, the turbine and the generator. This is the dynamic duo of power. Think of the turbine as just a giant, super fancy pinwheel. The whole goal is to get this thing spinning. Why? Because it's connected to a generator. And all a generator does is convert that spinning motion into electricity. A magnet spins inside a coil of wire, creating a flow of electrons. And bam, that's electricity. So the name of the game is simple. Find a way to spin that turbine. So this is the basic recipe for almost all the power on Earth. Step 1, you find some kind of energy source. Step 2, you use it to spin a turbine. Step 3, that spinning turbine activates the generator. And step 4, you've got electricity. Keep this process in your head because we're going to see it over and over again. Okay, now that we know the secret, spin the turbine, let's look at the first major way we do it, with heat. Now the goal here isn't just to make things hot. The whole idea is to use that heat to boil a whole lot of water, create incredibly high pressure steam, and then use that powerful steam to blast the turbine and get it spinning. And this is the classic, the old school method. We take fossil fuels, coal, oil, gas, which is all just ancient stored up energy from plants and animals, and we burn them. This releases a ton of heat, boils that water, makes the steam, and spins our trusty turbine. So what's the deal with fossil fuels? Well, the pro is pretty obvious. They are incredibly powerful and super reliable. We can burn them day or night to power our entire world. But the con is just as big. They're not renewable. Once they're gone, and burning them has a major environmental impact. That's the trade-off. Now, biofuels are kind of similar. We're still getting heat by burning something. But instead of digging up ancient fuels, we're using things that were alive much more recently, like wood chips, corn, or sugarcane. It's the same basic process, just a different, fresher set of ingredients. The big plus here is that biofuels are renewable. We can just grow more, right? But, of course, there's a catch. Growing all those crops takes up a huge amount of land that could be used for food. Plus, they just don't pack the same punch as fossil fuels on a massive scale. Okay, but what if we could get all that heat without burning anything at all? Well, that's exactly what geothermal energy does. We're basically using the Earth itself as one giant natural boiler. We pump water deep underground, the planet's core heats it up into steam, and that steam comes back up to spin our turbine. Pretty cool. So, geothermal is awesome because it's renewable and it's incredibly reliable. The Earth's core isn't shutting off anytime soon. The major drawback, though, is location, location, location. You can only do this in specific places, geological hotspots. So as great as it is, it's not an option for everyone. Now let's talk about the most intense way we know how to boil water, nuclear power. It's all about splitting atoms. Inside a reactor, a process called fission releases a truly staggering amount of heat from a very small amount of fuel. And what do we do with all that heat? You guessed it, we boil water to spin a turbine. Nuclear power forces us to face a massive trade-off. On one hand, you get a mind-boggling amount of clean, reliable electricity from a tiny bit of fuel. It's incredible. But on the other hand, that fuel isn't renewable. And then you have the huge challenge of what to do with the radioactive waste, which stays dangerous for thousands of years. Okay, so we've covered all the different ways we can boil water to make steam. But what if we could just skip the whole boiling part? What if we could use the forces of nature to just push the turbine directly? That's what this next batch of energy sources is all about. And hydropower is the perfect example. It's so simple. You just use the force of moving water, whether it's a huge river held back by a dam or the natural ebb and flow of ocean tides, to physically push the blades of a turbine and make it spin.
Water power is fantastic because it's renewable and, especially with dams and tides, it's super reliable. But just like geothermal, it's picky. You need a big, powerful river or just the right kind of coastline. And building massive dams can have a really significant impact on local ecosystems.
Wind power is another really straightforward one. The sun heats up the planet unevenly, which makes the air move around. That's wind. And all we do is build these enormous turbines with blades designed to catch that wind, and as it blows, they spin. It's a beautifully simple concept.
So, wind is clean, it's renewable, it's great, but it has one really big Achilles heel. The wind doesn't always blow. This is a huge challenge called intermittency. It means that if the wind dies down, you're just not making any power. It's a fundamental problem for some of the biggest renewables.
So far, literally every single power source we have looked at depends on that one critical step, spinning a turbine. But what if I told you there's a way to make electricity that breaks the rule? A way with no moving parts at all? Well, it's time for the plot twist in our story of energy.
This is the magic of solar panels. They're made of these special materials called photovoltaics, and when sunlight hits them, it literally knocks electrons loose inside the material, creating an electric current. It's a direct one-to-one conversion of light into electricity. No spinning, no steam, nothing. It's a completely different way of thinking about power. The best thing about solar is that it's renewable, and you can put it almost anywhere on the planet. But just like wind, it's not always reliable. The sun goes down every single night, and even a cloudy day can seriously cut down the power you're making. So yes, it's another intermittent source. So after all that, what's the big takeaway? Well, if you look at this chart, one thing becomes crystal clear. There is no perfect energy source, no silver bullet. Every single option comes with a unique set of pros and cons. Choosing how to power our world is a constant balancing act between these key factors. Is it renewable? Is it available? Is it reliable? Can it scale up? And what's its impact on the environment? And that leaves us all with a really big question to think about. As we plan for the future, we have to decide what our priorities are. Is the most important thing having power 24/7 no matter what? Or is it protecting the planet above all else? The choices we make about this balance will define the world for generations to come. So what do you think? What do you value most?